Friends, today we are going to discuss about a new topic. Before that, we already discussed what is distance, displacement, speed, velocity, and last one acceleration. The section speed we discussed about, in the section velocity we discussed about initial velocity and final velocity. What is initial velocity? The starting velocity, and the letter used to represent initial velocity is small letter u. Final velocity is represented by small letter v. And acceleration is v minus u divided by t, isn't it? So there we reached. Hope you write your notes up to that. And we already done the questions based on these sections, questions based on average speed, acceleration, these things we already discussed in our class. So we are moving to graphical representation of motion. Remember that there is some more problems based on acceleration and we will be doing it on the way. Okay, now we are taking this distance time into a graphical representation. What is a graph? See here, I have a two-dimensional graph. You know what is a graph? A graph consists at a minimum of two variable quantities. Why it needs a minimum of two variable quantities? To represent in the x and y axis. Even if it is three variable quantities, we will have another axis here, that is z axis. So here we are discussing about only the two-dimensional graphs, that is xy graph. Here we already discussed what is distance and the relation between distance and time with an equation. What is the relation between distance and time? Speed equal to distance by time. That was the relation between distance and time. Now we are finding this relation using a graph. See here, let us consider an example. A body travels 20 meters in every second. Let it be time. So at 0, it travels 0 meters. And distance here. Time is given in seconds and distance is given in meters. Let it be in the SI units itself. At third second, it reaches at 60 meters, fourth one 80, and fifth one 100. What is the nature of this motion? Is it uniform or not? It's a uniform motion, isn't it? Why it is uniform? It covers equal distance in equal interval of time. At every 1 second, it covers 20 meters. So it covers equal distance in equal interval of time. Now I am considering another example, another body. This is the first one. Now second case, another body whose time and distance is at 0 second, it was already at 10, the distance 10. It already covered a distance of 10 meter. So at 0 it was in the position 10, and when it covers 1 second, again the position was in 10. When it covers 2 seconds, again the position is at 10, 3 also 10, 4th one also 10. See here, the time is moving but the distance is not changing. What that means? The body is at rest. See here, if I have a point A, I have a point B here, 10 meter away from A. Now our body is at B. At first second, again the body is at B, because it is in the same position at 10. Second also it's in the same position B. And third also it is in the same position B, because it is not moving. See here, it's always 10. The position is not moving. Always at a same distance it is following. See, from first second onwards to the fourth second, it have the same position. So we can say that the body is at rest. In the first case, the body is in uniform motion, and in the second case, the body is at rest. So now let us change these numericals into a graphical format. So first of all, let us draw the graph of this one. Distance time graph of second case. See, we have to take distance along y-axis and time along x-axis. This is the important point to remember. While drawing a graph, distance time graph, you have to take distance along y-axis and time along x-axis. So we can take the time here. It is Time is given in 1, 2, 3, 4. So we can write it here. 1, 2, 3, 4. Now the distance, we can write 2, 4, 6, 8, 10. So at the first second itself it is at 10. Second also it is at 10. Third also it is at 10. Fourth also it is at 10. See, the graph is a straight line. The graph is a straight line parallel to the x-axis. Graph is straight line parallel to the x-axis. So if a graph comes like this, we have to understand the object is at rest. So this is the first graph when the object is at rest. The graph is a straight line which is parallel to the x-axis. Sometimes the question will be, they will be only giving this graph, a graph like this. These things will not be given. They will be only giving this graph and ask, explain the nature of the object, nature of the motion. So you have to just write the object is at rest and the position of the object is at 10. If you write so, you will be getting full marks. So see here, the nature of the graph, the nature of the motion is very clear from the graph. That is, the object is at rest. At first second, second second, third second and fourth second, the object remains in the same position and there is no change in the position, and hence the object is at rest. Now, to see the difference from the object at rest, let us draw the graph of this one. Uniform motion. Graph of uniform motion. Let's check how it comes. So we have to take the distance along y-axis and time along x-axis. Time again we can take 1, 2, 3, 4, 5. Now distance is 0, 20, 40, 60. So 20, 40, 60, 80 and 100. Now we can depict the points. At 0, the position is at 0. Yes, first point is that. At first second, 20. 120. This is 120. Then at second at 40. So we have to draw here 240. You have to write the cardinal points there, coordinates. 360. So here we can draw 60. Then about 4, it is at 80, here, almost here. Okay, and last one at 5, it is 100. 5, it is 100. And when we join these points, so if you draw it with a scale, you will get a straight line inclined to the x-axis. In the first case, it was parallel to the x-axis, and the second case, it is inclined to the x-axis. There is an inclination, isn't it? The line is again a straight one, but is inclined to the x-axis. And what is the nature of motion? See here, it covers equal distance in equal interval of time. Therefore, is the graph of uniform motion. So if a graph is given like this, a straight line which is inclined to x-axis, and if you are asked to write the nature of motion, you can write the graph follows or the object follows a uniform motion. See, hope it is very easy for you. Now going to another section. So we have two cases in distance time graph. First one when the object is at rest, and second one when the object is in uniform motion. We got two cases. Now we are finding speed from the graph. How can we find speed from the graph? We know this equation of speed. Speed equal to distance by time. Instead of d, we will be using s. S by t, distance by time. So if the graph is given for us, we need not go to these numerical terms. We can find easily from the graph itself. There is an easy method to find speed from the graph. Let's check what is that method. So take any 2 points. You can consider any 2 points in the graph. Now I am considering these 2 points, and extend the point downwards. Extend a line from the point downwards and from here to the right side. Okay, what we have done, extend it downwards from the first point, and from this point we have to extend it to the right. You can take any 2 points. You can do with these also, these 2 points also. There is no problem. Actually, what we are doing is we are calculating the slope of this line. This line is an inclined line, isn't it? It's not straight, it is an inclined line. So we are calculating how much slope does it have. എത്രത്തോളം ചെരിഞ്ഞിട്ടാണ്. That we are calculating from this. Now see, extend this point to the y-axis. It is at 80, and this point to the y-axis too. And now these 2 points to the x-axis also. Now the slope of the graph equal to, we can name this point A, B, C. So slope of the graph is equal to AB divided by BC. What it is? AB divided by BC. This is general formula for finding the slope of the graph. If you are given any graph, let it be in mathematics or physics or chemistry, let it be anywhere, if you are asked to find the slope of a graph, just make a triangle like this and name it ABC, starting from the first point. Topmost point you have to name it A, B, C. Now slope is equal to AB divided by BC. AB. So what is AB? What is this distance? Let us extend this to here. So we get this 40 to 80. What is 40 to 80? 80 minus 40. What is that? 80 minus 40 divided by, now what is BC? This much distance. So in order to find that distance, we extend it to the x-axis. What is it? 4 minus 2. 4 minus 2. Why do we write 80 minus 40 to find this distance? The total distance is 80 and up to this it is 40. So from this 80 we minus this 40 to get this much distance. So this is 80 minus 40 and the answer is 40. Now we consider here. What is 4 minus 2? The total is 4 and we are minimizing this 2 from the total. So we get this distance, that is 2. It's equal to 20. Slope of the graph is 20 and it's the speed of the graph, 20 meter per second. Now we can check this with a numerical method. Do you remember the database? That is, at 0 the distance was at 0, and at 5, at 100 meters it covers, when it covers 100 meters it takes 5 seconds. So from this we can calculate the speed by numerical method to check whether it is true or not. So the distance covered is 100 and time taken is 5. 100 by 5 is equal to 20 meter per second. See, we don't want to go for these numerical sections. If the graph is given for us, we can find from the graph itself. Consider any 2 points and take the slope of the graph, you will get the answer. Now for you, I am taking another 2 points. It's enough. But if you are not clear with this, let you be clear with this topic. Now I am taking another 2 points. Let me take these 2 points. You can take 2 or 3 points, no problem. These 2 points. I am taking these 2 points here and here. This one. Fourth and third point. 1, 2, 3. Third and fourth one. Okay. So let me extend this line to the x-axis and to the y-axis also, and name it as A, B, C. Now slope of the graph is equal to AB. What is AB? 80 minus 60. What is 80 minus 60? That is, let me write it, AB by BC here. The next step we can write, what is 80 minus 60? 20. Now AB by BC. What is BC? 4 minus 3. What is 4 minus 3? It's 1 is equal to 20 meter per second. Hope it is clear for you now. So today we explained first type of graph, that is distance time graph. Based on distance time graph, there is two cases. First one, when the object is at rest and when the object is in uniform motion. And when the object is in uniform motion, we can find the speed of that object, speed of that particular object by finding the slope of the graph. When we find the slope of the graph, that itself is the speed of the object, that is equal to, here it is equal to 20 meter per second. Hope this section is clear for you. Thank you for listening.